Okay, we're to graph the solution set to this system of linear inequalities, which means we have to graph each linear inequality on the same plot and look at the overlap. Okay, so first of all, step one is to graph the first line, y plus 4x equals 5. So we need a little xy, two points on the line to graph it. If x is 0, then 4x is 0 and y is simply equal to 5. And another point would be, say, if y is 9 and x is negative 1, because 9 minus 4 equals 5. So there's 2 points on the line, so we can graph it. I'll graph it over here. 0, 5, so let's call this 1, 2, 3. Well, I need to go up to 9. I better make this graph a little larger. So we have to go up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Because negative 1, 9 is a point on the graph. So I put the 9 on this side. There's negative 1, 9. That's the second point. And 0, 5, 2, 3, 4, 5 is the intercept here, the y-intercept. So this line comes down rather steeply, and it's dashed because we don't include that. So there's the graph of the first line, and we need to decide which side of that line to shade. So we can ask, is the origin shaded? We answer that question by taking the original inequality, y plus 4x is less than 5, and plugging in x equals 0 and y equals 0, so this whole left side becomes 0. And since 0 is less than 5, the answer is yes. The origin is on the shady side of that line. So the first region is everything to the left and down from the first line's graph, not including the line. And now we do the same process for the second equation inequality in our system of linear inequalities. So the first step of this one is to graph the line y is equal to x plus 3. So finding a little xy pair, a couple of them for this. If x is 0, then y is 3. That's the y-intercept when x is 0. And we can also let x equal negative 3, because negative 3 plus 3 adds up to 0, then y is 0. So there's 2 points on this line, so we can graph it. 0, 3, 0, 1, 2, 3, here's the y-intercept at 3. And then negative 3, 0, negative 1, negative 2, negative 3, 0 is here. So here we have a line through these 2 points. Also a dashed line because it's a strict inequality. It doesn't say or equal to, so we're not including the points on the line. So here we get this dashed line. And finally, we have to ask, which side of that line do we shade? So we can ask, is the origin shaded? Once again. And we answer this by trying to plug x equals 0, y equals 0 into the original inequality here. See if it's true. So we plug in x equals 0 and y equals 0. You get 0 is less than 3. And that's true. 0 is less than 3, so the origin is on the shady side of that line. Therefore, there's the origin, it's the downside. This you could have also recognized by realizing that this was in slope-intercept form, and y equals x plus 3, and y is smaller than x plus 3, means it's the bottom below that line. So now the overlap of these two regions is the solution to our system, and that's everything in here, not including the boundary lines, but everything in between. This whole wedge here is a solution region.